Hi everyone, I'm Hongfei Ma. Today I will show you a presentation about V2X networking challenges around autonomous cars. I will introduce it in four parts. The first part is what is V2X. The second one is its technologies. Next, I will show you some challenges in this area. Finally, I will list some useful resources that can help you understand V2X. There are a lot of terminologies in this area. I will try my best to elaborate it without them. And if you are interested in some part of it, please read the resources I list on the last slide. First, what is V2X? V2X is vehicle to everything. It's the communication between a vehicle and any entity that may affect or may be affected by the vehicle. It is a communication system that incorporates other more specific types of communication, such as V2V, V2I, V2P, and V2N, and so on. But why it is important to our life? Let me take an example. Nowadays, nearly everyone has a smartphone with, yes, and we can use cell phones to make a payment in shopping mall, take public vehicles, and play video games for entertainment and so on. But can we predict these things 20 years ago in 2000? I think the answer is no. A cell phone can only make a phone call at that time. Therefore, mobile internet did change our life. Now, come back to our V2X. Generally speaking, vehicles are the tools that we can use to get ourselves to the destination. But make an analogy of cell phones. Is it possible that our cars can be smarter like smartphones today? It is more than a vehicle. It can entertain us and we can watch video while driving without a steering wheel. It can also choose the best route without any traffic congestion and something like that. That is what V2X do. Vehicle to everything that can help, that can make our life better. Now, I believe you have a brief understanding of V2X. Let's take an let's take two examples. The first one is V2V. V2V communication enables motor vehicles to access information about the speed and the position of other V2E enabled vehicles surrounding it. The data is then used to alert drivers of potential dangers, helping to reduce accidents and traffic congestions. V2V can detect dangerous traffic and road conditions and some weather stress within a range of 300 meters. V2V has the power to make driving a more predictable and safe activity for everyone on the road. The second one is V2I. It captures data such as traffic congestion, weather advisories, bridge clearance levels, and then wirelessly transmit it to inform drivers of condition they need to be aware of, which is in safety. Smart traffic signals powered by V2I helps drivers understand traffic conditions better, helping to estimate accurate arrival times, which can improve communication between drivers and customers. V2N is to connect the vehicle to the network, which is easy to understand, and V2P is similar to V2V. Let's skip it there. Now, how we can achieve the goal of V2X? Let's look at some technologies. DSRC, the full name is Dedicated Short Range Communications, and CV2X. The first one is DSRC. It is one-way or two-way short-range to medium-range wireless communication channels, specially specifically designed for automotive use and a corresponding set of protocols and standards. Maybe you can treat it as Wi-Fi. Each vehicle is a router which can send out and receive signals. The primary motivation for deploying DSRC is to enable collision prevention applications. These applications depend on frequent data exchanges around vehicles and between vehicles and roadside uh, infrastructures. The basic the basic of DSRC-based collision avoidance is illustrated on the picture. Each DSRC-equipped vehicles broadcasts its basic state information, including the location, speed, and acceleration several times per second over a range of a few hundred of meters. Each vehicle also receives the safety messages from DSRC-equipped neighbors. A receiving vehicle uses these messages to compute the trajectory of each neighbor, compare this with its own predicted path, and determines if any of the neighbors poses a collision threat. The structure of DSRC is complicated. I just put a picture here, and if you are interested in a paper published by John Kenny, may help you understand. The link is on the last slide. Now let's look at CV2X. But DSRC, just as its name indicates, the system lacks a mechanism for long-range communications. After some initial interest by car makers, DSRC has failed to gain much traction. In the past few years, key transportation ecosystem players in China, Europe, Japan, and the US have alleged to support the CV2X standard. Numerous field trials have proven that the technology is ready to deployment, and many pilot programs are now underway. So how it works? The CV2X standard defines two complementary communication methods. Let's look at it here. A cellular radio link, the UU, for long-range broadcasts, and a satellite called the PC5 interface for short-range messages. Because round-trip communications through LTE cellular networks could add an unacceptable delay to time-critical safety messages, CV2X used the Starlink for short-range V2V and V2I communications, which is less than about 1 kilometers. The Starlink broadcasts on 5.9 megahertz spectrum, employing an updated version of the LTE directed device-to-device link. Besides reducing latency, the Starlink eliminates the risk of failure due to a lack of cellular coverage. In CV2X, the cellular V2N link supports less time critical long-range communications, which is the cellular link, such as broadcasting alerts of an accident up ahead that beyond the reach of satellites. The link broadcasts using the same licensed spectrum as traditional cellular communications, connecting vehicles to metro base stations or some other small cells. CV2X technology is the key that will finally unlock the promise of intelligent transportation systems. Pilot programs are underway in nations around the globe, and in 2021, the first production vehicles integrating 5G and CV2X will begin production in China. Now, let's talk about the challenges in V2X. I want to separate it into two parts. The first one is the technology challenges, and the second one is some other challenges other than technologies. Now, let's look at technology challenges. There are too many challenges in V2X. Here, I just mentioned two of them. If you are interested in technology challenges, please read the paper on the last slide. I think it is the fifth item. It was published on June 2020, which is very new. The first one is efficiency of authentication. Authentication has been mentioned by Romit in security part of communication networks. According to the DSRC standard, each vehicle is required to send safety-related message at every 300 millisecond intervals, imposing a burden on each vehicle and the receiver by verifying hundreds of messages every second. Based on this concern, the authentication schemes must be efficient enough to accommodate the stringent delay constraint. Researchers mainly focus on reducing the computation and communication overhead in vehicle networks. Indeed, many schemes support batch verification have already achieved good performance for efficient message verification. However, there are some issues in batch verification, such as the low success probability of batch verification and inefficient rebatch algorithm. Such a success batch verification result requires that all the signatures are valid and with no transmission error. A single mistake will cause the failure of batch verification. Under some dense scenario, both the large number of signatures and the high-level noise exist in data transmission process may severely degrade the performance of batch verification. Thus, an efficient rebatch algorithm is expected for the batch verification schemes. The second one is the compatibility with the heterogeneous networks. In the future, 5G V2X is likely to be the major radio access technology for V2X services. Thus, new security solutions should consider the heterogeneity of 5G environment. Moreover, the V2X services also belong to the big family of Internet of Things, in which the heterogeneity of the network must be considered. From another point of view, 5G V2X not only brings challenges but also attributes like uh, like ultra low latency and high data transmission rate. Thus, new solutions may be relieved from constraints in DSRC and take the advantage of the new network architectures. The next part, other challenges, I think it is more difficult than technologies, such as ethics, policy, and something else. The ethic challenge is that who decides who lives and who dies in split-second decision making, who decides the value of one human life over another, and more importantly, how is that decision calculated? Being on a road is inherently dangerous, and this danger means that trade-off will occur as self-driving cars encounter life or death situations. It is inevitable, and with trade-offs, we need ethical guidelines. Policy challenge is hard to describe, but you can record the policy and economic problems in ISPs that Romit has mentioned in the class. Different areas has different policies, and how to cooperate them is also a tough problem. As you know, there are also some other challenges uh, like social acceptability and something else. I placed a paper on the next slide, which is related to the mortality of self-driving cars and human drivers in dilemma situations. Now, here are the resources that I have searched on the internet. They are all PDF document links, and if you are interested in it, please download and read it. I hope this will help you. Thank you.